And welcome to our next Chance and Data external revision video. We're going to chat about time series, and we're going to start with the 2020 external example. Now, time series is a graph where we measure time on the bottom, on the x-axis, and we measure some variable on the y-axis. And in this example, we're measuring the population of the troughs bird, or the banded dotterel. Now, the first question they asked this year was to estimate the population of the bird in July of 2017. So you grab your ruler and estimate where you think July 2017 would be, and I reckon it hits the graph and comes across just under 900, so I'm going to guess about 890 birds. All right, well, this is a general statement we could say about this graph. The population of the troughs is increasing and decreasing each year between January 2015 and January 2021. The highest population recorded was about 1,800 birds, which happened to be in February of 2015, and the lowest population recorded was about 50 birds, and that was in January of 2017. Notice, lots of detail, and we're using numbers as evidence. Okay, what's next? Well, what I like to do with my ruler is put a line through all these peaks, the highest values. I'm not going to get them all. And put a line through all these bottom peaks, the troughs. And again, I'm not going to get through everything perfectly. And then I'm going to draw a line right through the middle of these two lines. And this is called the line of best fit, or the trend line. Now, we can say the following. The population of the troughs is slowly decreasing between January of 2015 and January of 2021. Now, to explore this in more depth for merit and excellence, we're going to look at the gradient. We know it's a negative gradient because it comes down, and we know gradients rise over run. So I'm going to work out how much it rises down. Now, it starts off at about 1,000 birds, and it drops down to just under 800, so I'm going to estimate about 220 birds drop. And it takes 6 years for this drop to take place. So our gradient's minus 220 over 6. Now, if you get your calculator and go 220 divide 6, you get about 37. So it's a gradient of minus 37, or approximately. I'm going to carry on and say the following. The population is decreasing by about 37 birds each year. Okay, well, what's next? Well, we're going to look at what we call seasonal patterns. And these are what we call peaks, our highest points. And we notice they happen just after January each year. So you could pause the video right now and read this detailed comment about what we could say about these peaks. We could explore the peaks in more detail because notice once they reach the maximum population, they drop off a little each peak. And that could be because the babies are born and either predators or starvation. Unfortunately, some of the babies don't survive. All right, well, we can carry on with seasonal patterns and talk about troughs, our low points. And again, you can pause the video now and just quickly read this detailed sentence of how I describe these troughs. And again, you might wish to explore some of the troughs in more detail, especially this trough here, just before the beginning of 2017. Well, what else do you need to know about time series graphs? Well, in the 2016 external exam, they had a gap. There was no data for this particular time period. In the 2019 external, this was about the points scored for the New Zealand rugby team. They had what we call a spike. It's like an outlier. And about 2005, they scored a huge amount of points for some reason. And in the 2018 paper, there are a couple of things we need to talk about the trend. First of all, the trend can be broken up into different pieces, and we call it piecewise. Sometimes because of this, we might have to shift the graph a little and change it from one place and shift it up or down a bit. And finally, you might decide, I don't want to do a linear trend. I want to do a trend which is a curve, a non-linear trend, a growth curve or something like that, which is a better trend than a linear model. All right, well, thanks for watching, and I hope this has given you lots of advice for the actual exam.